In this video, we're going to do number 39 from section 6.2. So in order to really understand this problem and the work that I show for it, it'd be very important and beneficial for you to have the book right in front of you so you can read the context. I'm going to read the context out loud, and then we're going to try and go through the questions together. So Miss Hall gave her class a 10-question multiple choice quiz. Let X equal the number of questions that a randomly selected student in the class answered correctly. So X is number of questions answered correctly. Computer output gives the information below about the probability distribution of X. To determine each student's grade on the quiz out of 100, Miss Hall will multiply his or her number of correct answers by 5 and then add 50. G is going to be the new grade of the randomly chosen student in the class. So our old variable is correct answers. G is grade. So you're converting X into G. What is that exact equation that you do that by? Well, G is going to be equal to 5 times X plus 50. So how many total transformations are there here? There's a multiplication of 5 and there's an addition of 50. So if we're going to find the, like part A, it says find the mean of G, show your method. If we're going to find mean of G, we're going to be doing two operations here. We're going to find 5 times the mean of X, and then we're going to add 50 to it. Because remember, whether you add or multiply, both affect the mean. And we'll get to what happens to the standard deviation next. So the information given, mu X, is actually given to us in the book. The mean is 7.6 plus 50. So when you multiply 5 times 7.6 and then add 50, you get an average of 88. So the mean grade for the variable G is 88. That's part A. Let's go on to part B. Part B asks for the standard deviation of G. Show how your method. So we need to find sigma G. Now, sigma G is going to be equal to 5 times sigma X. You might be wondering why. Why is there not a plus 50 over here? If you recall, when you add or subtract a number, it affects only the mean and not the spread, standard deviation, or variance, or anything else. Okay? So only going to do the multiplication transformation, not the addition one. For the mean, it's different. It gets both, but just for the measures of spread, it only gets the multiplication. So sigma G is going to be equal to 5 times sigma X. And from the book, 1.32, that's your standard deviation. So your new sigma, your new standard deviation is going to be 6.6. So to recap, whether you add or subtract, both get applied to the mean. Only the multiplication or division gets applied to the standard deviation. Question C, how do the variance of X and the variance of G compare? Justify your answer. Well, if you have the standard deviation of G and you have the standard deviation of X, you could simply square them. Standard deviation of X is 1.32. Standard deviation of G is 6.6. If you wanted to find this, you could square it. 6.6 squared. You should get approximately 43.56. If you square 1.32, you get approximately 1.7424. Now, how much bigger of a variance? How much bigger a variance of this is compared to this? Do a ratio. Divide those two numbers and see what your factor is. So 43.56 divided by 1.7424, you get 25, which is weird because we didn't multiply by 25, we multiplied instead by 5. But here's the situation. If you want to increase your variance or standard deviation by 5, you actually increase the variance by 25. So this is your sigma, or your sigma G squared. That's going to be equal 5 times your sigma X squared. And when you square your old standard deviation, you actually square the 5 as well. And this turns into 25 sigma x squared, because 5 squared is 25. So standard deviation, factor of 5, but the variance, because it's the square of the standard deviation, it's a factor of 25.